All right, guys, so piecewise functions, just another review of those. Hopefully we're already starting to pick up the pattern and you see where this is. It's not that much different from Math 1. We've only added some small things. So if we were to cover up these little mini domains, this is the unit of function notation from Math 1. So knowing that f of x, in this case, the x was replaced with a -2, so it is going to go in the place of x. 7 was replace the x here, so 7 is going to go in the place of x. And again, remember, f of x is the same thing as y. So that's all Math 1 information. The addition is now our little miniature domains. And remember, domains are your x values. So it's setting parameters for what x values work for each function. As you guys have picked up, I'm a big fan of color coding because I have the attention span of a squirrel. And it helps me to notate and to just be able to communicate without having to read long equations and to stay focused. So if we're doing these, if I look at the first problem in this case, f of -2. So you're going to look at your domains. Is -2 less than or equal to a +5? So is -2, so you're literally thinking, and if you need to write it down to see, is -2 less than or equal to 5? This case, yes, but let's make sure and check it doesn't fit another one or something crazy is going on. So between 5 and 10, does -2 fall between 5 and 10? And when you think about a number line, so 0, and we could call this 5, and then all the way out here is 10, -2 is over here. So if you don't know here, make a number line at the top of your page. -2 does not fall between 5 and 10, so we are going to use our blue function. So that means this is going to be a blue function. And then, so if we go ahead to number 2, f of 7, does 7, is it less than 5? So is it to the left of 5, or does 7 fall between 5 and 10? 7 does fall between 5 and 10, so we are going to use the yellow function. And all you're going to do, and I, as you've picked up, am a big color fan. So I'm going to write the equation just as is, but x goes away, and x becomes a -2. Big call out is be careful, because in your calculators and such, you guys just like to type in -2 and like square it in the future, like using it, or like you'll drop this negative because there's a negative here. If it's there, it lives there. When you have -2 and you do have to square it, like say in like number 2 over here, be sure to use those parentheses when you put the -2 squared, or otherwise your calculator thinks you're squaring the 2 and then multiplying by -1. So it's just a communication error between you and your calculator. Speaking student versus speaking calculator. So usually I like to make it a good habit to always put my negatives in parentheses, and then it sort of fixes itself and I don't have to think about it depending on the style of the equation or the problem. Now, negative gives us a positive, so that's going to be a +2 minus 4. So our answer is going to be a -2. For our +7, we're going back to our yellow function. So that's 2x squared minus 7, and we're going to put that 7 in the place of x. It literally replaces the x value altogether. So we're going to put a 7 in the place of where x was in the equation above. PEMDAS, so order of operations, you're going to square your 7, which is going to give me 49. So it's going to be 2 times 49 minus 7, and then 2 times 49 is going to give us 98. Minus 7 gives us 91. Ta-da, you're done with that guy. Looking at number 2. So again, I'm going to color code. So that way we can talk pink and colors instead of all the fun other stuff that's on here. So pink versus green. F of -5. Is -5 between a -15 and 0 on a number line, or is it between 0 and +15? So 0 to +15 would be to the right. -15 to 0 would be to the left. So f of -5 at that rate is -5 to the right of 0 or to the left of 0. It is to the left, so we're going to go with our pink function on this guy. +15, is it to the left of 0 or is it to the right of 0? It is to the right, so this is going to be our green function. In this worksheet, it is just coincidental that they're one of each. There is no promise that it is going to be one of each. And there could be 4 functions and 10 problems below it. So this is just a kind worksheet where you get to practice all the things, if kind worksheets are a thing in math. So we're going to go to our pink function, which is just x squared. This would be a perfect one where I'm talking about you guys get excited and don't understand. And for whatever reason, you think a negative times a negative squared is going to give you a negative because the calculator tells you that. But if I ask you, you know that a negative times a negative is going to give you a positive. So again, it's a miscommunication between you and your calculator. So just be aware. You don't want to mess up on something so simple. So negative 5 times a negative 5, or negative 5 squared, is going to give me 25. 15, we're going to our second function, so that's x minus 5, and our x value is 15. So 15 minus 5 is going to give us 10. Now, for those of you who are visual learners, you will know, you will either take to this version of piecewise functions first, or you will enjoy a visual graph. So you can use a graph to solve these as well. And remember, you always have Desmos, which makes beautiful graphs. So to the conversation of this set, x squared and x minus 5, you have to type in your equation. You can use f of x or you can use y. Type in your equation. You're going to use the not parentheses, not square brackets. If you're looking at your keyboard, it's above enter, above the square brackets. So you're going to hit shift, get the squiggle brackets, which is like your list, and you're going to type in your domain. So negative 15, your, it went away. Sorry. Less than or equal to, I need to move it. There we go. Less than or equal to, because that's what's on the paper, x less than or equal to 0, and then you close that. And what that does for you is it does graph that x squared function. So just the part of the quadratic that falls from negative 15 to 0. The one thing it does not differentiate for you is whether it is a solid line or a solid circle. So does 0 include in this graph or does it not? Because it doesn't do open circle, closed circle. So you have to pay attention to that equal to here, meaning that that 0 does work for this function. Whereas in your second function, it's 0 is less than. There's no equal to. So that means 0 would be an open circle for here at 0. So normally, like graphically on worksheets and most of the pictures of these functions, you will see open circles versus closed circles. So this guy would have a closed circle again, and this guy would have an open circle. But if you click it right now, it tells you it has a solution, and it does have a solution theoretically, but it does not count because of the lack of the equal to here. So the domain changes it. But if I plug in a 0 in this equation, that's where that negative 5 comes from. So the interpretation is still left up to you. Now, the way you could use this is knowing that for our first one, we had to go to negative 5. So if I come over to negative 5, if I look down, the red graph does not exist there. The black graph does appear to keep going up. So we're going f of negative 5, and you have to slide around a little bit because obviously that's not negative 5. So just take a minute, and there you go. Your output is going to be 25 because that f of negative 5 that we've seen, and when I say f of negative 5, I mean this. As a question, it is stating when x is negative 5, what is y? And that's why you can come over to your graph, and when x is negative 5, and you want to get dead on it, y is going to be 25. Now, if you notice here, it gave us a 25. That's awesome. The problem, if you're not paying attention, is typically most of your worksheets, all of them are f of x, right? So in this case, when you have them both f of x, it can't solve it because it doesn't know which function to use. So if you can mentally make the split so it knows which function to use, you can change it to g of x. You still have to decide by looking at the graph or knowing which domain that negative 5 falls in, whether you want to use the black function or the red function. But obviously you saw there was no red function over here at negative 5, so you know to type in f of negative 5. So if I wanted to know positive 5, your worksheet would say f of positive 5 because both of these were f functions. We just changed it to g, so it would do what we wanted it to in Desmos and give us those answers. But obviously at positive 5, the black function's way over here, and our red function is there. You can see it, positive 5, 0. But in that case, I could type g of positive 5, and I get 0 because when x is 5, y is 0. And then the second one was that 15 that we talked about. So 15 is over here, again, not your black function. So you could look at 15, go all the way up if you're visual, and that makes more sense, and you see that it is going to give you an output of 10, 15, 10. Or again, if you realize completely this is red, and again, you have to name these. So f of x and g of x both are y. This is the f and the g just basically say this is Frank and this is Gertrude. So it allows your calculator to know which one you're talking about. So g of 15 was the one we solved algebraically. And there we go, we have our 10 here as well. If you can understand how to separate these here and use these to your advantage, you get out of doing a ton of algebra and all those calculator mistakes I was telling you about. But worst case, you leave this as your f, and then you just come to your graph and look like 5, 0. 15 is going to give me that 10 because obviously, again, you see there's no black function over here. If I wanted to know, I don't know if there's another good one. Is that a good one? Let's check it. So at -2, we have a +4. So I could try f of -2, and when x is -2 for these functions on these domains, then our y value will be 4. All right, so moving right along, algebraically again. So number 3, 6 divided by x minus 1. The domain is when x is not 0. There is not a not equal to symbol in Desmos. So this is just when x is not 0, we're going to use this function. Then it says 3 when x is 0. So there's going to be a lot more times in this case that you're going to use your first function. So we'll color code again, sorry. So we would use our yellow function probably a lot more than you would use your 3. The call out to this guy, that second one, is there is no x there. That's awesome. Like that's a gift because that means there is no algebra to do. So when x is 0, the output will be 3. Period. Not 3 times 0, but it will be 3 because, again, there's not an x there, so you can't plug anything in. The answer is 3 when x is 0. So like when I said, what is y when x is 7? In this case, what is y when x is 0? It is 3. It's done. So in here, it would have been x is 7, y is 2x squared minus 7, and then you had to solve it to tell me that it was 91, or go graph it and go find it. I didn't do this graph in Desmos because it blows pretty big because 91's way off the page, and it's hard to see both of them until you scan way out, which makes it very difficult as well to kind of see your hashes and your numbering very well. It takes a lot longer to scroll around. So f of 3 is 3, 0. Hopefully that's a big no. And then is 3 not 0? 3 is not 0, so we are going to use that function. So we're going to do 6 divided by x minus 1, and in this case our x is 3. So 6 divided by 3 is going to be 2. Minus 1 is going to give us 1. So for this function, when x is 3, y is 1. When x is 0, so f of 0, again, is stating when x is 0, what is y? In this case, this one's great. This is beautiful. When x is 0, our output is 3, and you're done. It is 3. There, again, no conversation, no math. You're finished. I already put this equation in Desmos just so you could see it on this page. So again, to show you, they're both graphed at this point, and that y equals 3 is that vertical line, horizontal line here in the blue. And again, I can make it go away, add it, make it go away, make it go away. So this is that y equals 3. Y equals 6 divided by x minus 1 is here. And we just have to set up our domains. So our domain was x is not equal to 0, so that's everywhere but there. And like I said, if you find it, let me know. But I looked around and I Googled for a bit, and I could not find a not equal to. Functions, maybe over here. Let's do a quick check. Yeah, there's not a not equal to. So again, that's one of those things where you're just going to have to understand that it's not equal to 0 here. But you could also, when x equals 0, and it turns into this gray dot. So that is the only time you're going to use that function. So every other time you're going to use the red function for whatever number they choose to use. So like if we decided to do f of 6, it would be right here, which is 0, obviously see it. That one looks close, but probably not perfect. So when it's 1, it is 5. So if you want to play with Desmos 2, these are counting by 2s, not always my favorite. If you come over to your wrench, I'm not a big fan of the minor grid lines either. I want to get rid of those. Your x-axis, the steps, you can change it to be step by one, and I'm saying that like for your y-axis as well, because that makes it look like most of the graphs that you see. So if you want to alter it to look like the question you're looking at or the graph you're looking at, this is where you would do that. And then your x-axis, y-axis, these domains, if you remember working on your TI 83 or 84, when you would change your window, that's what this is. So negative 10, 10, negative 10, 10 was what the standard window is in a TI 83 or 84. They are trying to give you the standard window that is going to give you the most accurate, symmetrical, so you have perfect squares. So it doesn't skew the dimensions of your graph and make it look kind of crazy. So this is going to be your most accurately, like easy to identify. But the one by ones make it a little easier, in my opinion, to see. Like that would be 1, 5. When I get to 1, like I said, sometimes it takes a little time to slide around. 1, 5. Hopefully you see like this negative 2 is going to be there as well. Our 3, 0 did go away, which is interesting. But I don't know why it went away. It shouldn't have gone away. It should be right here. And I apologize. I'm not really sure why that dot went away. So maybe this is not necessarily a great one. That domain is not great to keep. But just showing you some more features of Desmos that you can mess with. If you happen to start standing in or way out, and hopefully this is not making you terribly nauseous, but you know you've done this where all of a sudden you're way up here and you can't find anything, this home default zoom will take you back to that standard window as well. So that will be your standard window back there. Trying to think of anything other good call outs on this guy as far as being able to use this to do what you want to do. Got nothing on this one. All right, back to the next problem. Let's go. So looking at number 4. This is awesome, except again, I don't think we have enough infinity for this guy either. But so we could just leave that off because infinity just means it's going to be all numbers that way. So x is going to be greater than 0 is a domain you could put in Desmos if you wanted to go see the graph. So if you are a more visual person, you can turn all these algebraic issues into a visual. And I feel like it went half and half last semester. Like people either really like doing the algebra and plugging it in, or they really like the graph. Whatever works for you, the idea is you have to get the question right, and you have to understand that these are domains, and then understand that this is plugging in for the place of x. So again, that conversation or the question that it's asking conversationally, not just in numbers, is when x is negative 5, what is y? And I don't know that a lot of math teachers explain that verbally, like in a sentence form. And in my mind, it makes more sense because then you know that that negative 5 is x and it has to plug in to give you an output. And again, this is y. So this is saying y is 14 when x is less than 0. Y is x squared minus 9x when x is greater than 0. So that's less than and equal to. So if we get a 0, it's going to go up here, which is awesome again because there's nothing to actually do except say that the answer is 14. Let's do our highlights. We have a blue function and a green function. So our first one is negative 5. Is negative 5 less than or equal to 0? Or is it between 0 and infinity? So from 0 to the right on your x-axis. It's all the numbers larger than 0 would be our green function. Negative 5 is not greater than 0. So it's going to be the one that, like I said, I think they're a gift. It kind of makes me giggle that they even do things like that because there is no math there to be done. So your answer is just 14. Walk away, you're done. Take it as a gift. And then f of 1. So is 1 less than or equal to 0, or is it between 0 and positive infinity, otherwise known as to the right of 0 on your x-axis or a number line? Your x-axis is a number line. If you can think back to like when you were in middle school and elementary school and they had the number line around the classroom, that is the x-axis. The only thing we did is we made it two-dimensional by going up and down with the y-axis on your coordinate plane. So that is domain. That is all those fun things that you've not necessarily enjoyed in high school and wish you could go back to before there was variables and you had one number line to deal with. X-axis is that number line. So he still exists in your life daily in your math class. He just looks a little different. He's matured. He's grown. So that 1 is going to go in our green function. So we are going to take x squared minus 9 times x. So that 1 is x. So when x is 1, not 1x. Like you are literally taking this number and putting it in the place of x. That x is gone. Then you're going to solve it. So 1 squared, which is 1 times 1 is 1. Negative 9 times 1 is going to be a negative 9. And so our answer should be negative 8. This one I do not think I have in Desmos yet, but we can put it in there and go try that out just again to show you in case you are a visual person. So we'll go to our next one. Oh, I do have it. Good, perfect. So 14, and this was when x is less than or equal to zero. We went outside our line. You have to stay in between the brackets. So less than or equal to 0. And then 0 is less than x. And I've never tried to do it backwards, but it works. Perfect. So you can see your parabola over here. Y equals 14. So that's why you can't see it, because we're at 6. So you're going to scan out a little bit, slide up maybe. And there it is, from 0 to everything smaller, because that's x is less than. So it's all your negative numbers. Again, your call out is that there is an equal mark here. So this is a solid circle. And there's not an equal mark here, so it does not actually exist in this function notation here. Oh, it tells us this time. Yay! 0 is undefined. Awesome. And I'm not sure why I did it this time and did not do it last time. I wish I could tell you. But undefined. And that is because there is not an equal to here. That's so cool. Some of this Desmos stuff I'm learning with you guys as much as anything else, because otherwise I would have to do a lot of problems by myself, and that's not as much fun. So when x is 0, we have a 14, obviously. When x is negative 5, so when I was saying, like, you have no algebra to do. When x is negative 5, come on, get there. It's 14. Obviously, it's going to be 14. All these numbers. So if you get excited and you want to try to multiply it, again, graph it and look at it. No matter what number you plug in that is 0 or to the left on your number line, the answer will be 14. And then for your other guy, we did it was 1 is what we looked at. So I would go to 1, and I could go down here and see that when it is 1, we have a negative 8, which is what we solved algebraically. And then again, just as a reminder, if you do f of negative 1, you're going to get nothing right now. See that exclamation point, and that's just saying, I'm confused, I don't know what you're asking me, because it doesn't know which function you want it to use. So in that case, we know that at negative 1, the blue function exists there, because at negative 1, there is no red function. So if we change the red one to g of x, or we can call it, I don't know, what's your initial? Let's do s of x, because it's sigma. So s of x. You can use any letter you want. F of x now, at negative 1, it should give me an answer, and it did not. Why would it not give me an answer? Oh, because we were doing positive 1. At negative 1, it should be s of x, because negative 1 is over here. Sorry, my mistake, guys. Getting excited all about this. I get so pumped on this Desmos taking away all the necessity to do math. It's so wild to me. So there you go. If you happen to put it in the wrong function, it will tell you undefined, since you've set up your domains, which again is really cool. So if you happen to get confused, if you get an undefined, you're in the wrong function. So you want to change it to the other letter in this case, and you would see that it's 14, because anything to the left of 0 is going to be 14. So f of 1 was the one we did on our paper, and that's negative 8, which is what we got when we solved it. If we happen to, again, have used the wrong function, like we just didn't understand, it's undefined, f of x. So you could actually just do trial and error as well in Desmos to make sure you get these right, which is pretty stinking cool and takes, again, a lot of the math away. It's kind of wild as a math teacher. You know, teacher-y me is like, oh, we need to learn the math. Julia Sigmund me is like, whoa, I would be so good at Desmos had I been in high school. This would be life right now. Enough of that putting things in calculator wrong and multiplying wrong or adding wrong. Completely over that. Passing that one down. Not doing it. That first one where I said it was kind of ugly, I did this. No, that's not it. I lied. I deleted it. It wasn't that one. Sorry. It was very ugly, though. Way big. Now, the fun part. So where students have gotten like their world rocked is when you see a problem like this. Again, this is no different than what we were doing in the beginning. It's just fancier. So looking at this algebraically, so some of you do understand your why. So we'll call this one our yellow function. The top one we'll do green. all of this is a fancified, very math 1 level, because again, I mean math 3 level, because again at the beginning, those were really math 1 level function notation problems with added domains. Now we're jumping into things that are very much math 3, because you haven't had to do a lot of this level math. You may have done a little bit in math 1, but not a ton, especially with multiplication and division. So f of 6, the 7 is saying that it's 7 times whatever the output is when you do f of 6. So if you wanted to make a side note, the question that you would be answering first would be f of 6 has to, 6. So we're going to write f of 6 equals, and that's going to be your question number 1 as you're doing your steps here. F of 6 equals, and then we have f of negative 9. So we have to solve both of those before we can even do this number 1, okay? So f of 6 is 6 less than or equal to negative 7, or does it fall between negative 7 and 12? It does fall between negative 7 and 12. So we're going to use our yellow function. And then f of negative 9 is negative 9 less than or equal to negative 7, or does it fall between negative 7 and 12? Again, you're thinking about that like middle school number line around your classroom that went in both directions. That negative 9 is going to be less than negative 7, so that is going to be one of our green functions. And then we're just going to plug it in. So into the yellow, that's 8 times x, and in this case, that x is 6. So 8 times 6 is going to give me 48. So the answer to that one is 48. Negative 9, we're going to plug that in. That negative 9 plus 2. So I owe you $9. I paid you 2. I owe you 7. Now, this is 7 times f of 6, which is 48, over 4 times f of negative 9, which we got is negative 7. So 7 times 48. Use your calculator, please. We are way beyond having to do this in our head. And even if you think you are great, that is amazing and fine. Try it, but double check yourself with a calculator, just because there's enough hard math to do without making minor multiplication errors, which are going to rock the world of the entire like math 3 level problem. And it happens. We make mistakes. I do it all the time, where you're just doing, and not thinking clearly. So 336 divided by a negative 28, sorry. There's one of those errors that I was talking about. And that gives you a negative 12. So it's a little more algebraic. So hold on to your britches. This one I do not have preloaded, but I did realize this as well. And this is either going to rock your world or make your life easier. Either way you do this, whether it be algebraic or you go to Desmos, the end of the day, I need you to get it right. So ask me more questions if you want to see more of anything or one way or the other, or you need me to do more for you. Again, just let me know. Holler. So we're going to put in those functions that we have on that one. And that first one was f of x equals x plus 2 with the domain of x is less than or equal to, I wish we had the less than or equal to on our keyboard. Less than or equal to, and it did it again. I'm sorry, guys. Less than or equal to negative 7. And when I hit the backspace one time, it takes the equal to away. So in the event you accidentally hit the wrong one, you can change it. And then I'm going to call this other one g of x like we did on that first page, because I want to differentiate between the two and see if they can do the math for me. Equals 8x. And our domain was negative 7 is less than x, and then less than or equal to 12. Whoops, wrong one. I hope you're following along on your Desmos. Because if you don't practice putting it in, you will forget how to put it in. And if you don't know how to put it in, all of this is in vain. So you have to use, again, the squiggles. You can't use parentheses. It's just your function, g of x or f of x. If you put them both in as y equals or both in as f of x, it's not going to know which one you're talking about. So just to circle back full force. The problem we had on our paper was 7 f of 6 divided by, and you probably could have done this parentheses before, I did it last, and then do 4f of negative 9. Now, it says undefined because, again, I did f of f, and it's only using the red function. And one of these does not fit that red function in this case, which would have been our green function. And that was the f of 6. F of 6 does not use the x plus 2. So then this one needs to be changed to g, and it's negative 12 like we got. Now, if that's too much to figure out, what you could do is, like I said, how we did 1, 2, and then we answered this problem. You could do f of 6, get undefined. You know that needs to be a g of 6, and then you get that 48 like we did, and then you can try the f of negative 9, and we get a negative 7. So now you know that the 6 needs to change to a g here, and then the f stays with that negative 9. So like I did on our paper, we did number 1, which was f of 6 to get the 48, and then we did number 2 is f of negative 9 to get the negative 7, and then we plug that in the place of. This could let you figure out which letter to put in front, so which function to use if you don't want to do all the thinking. Up to you. Lots of options here to either think mathematically or let Desmos do it for you as well. But again, at the end of the day, our answer was negative 12, and you just nailed it. So this could be a massively long equation as long as you break down each one and change your letters appropriately. Again, you don't have to do a lick of algebra at all, which is unnerving as a math teacher. But for that, I feel like that's enough for the moment on. I just really wanted to make sure we had enough review and you're figuring it out. I got a lot of feedback last year that Piecewise was not hugely easy to understand. You guys haven't told me much, and you're not really emailing or texting or showing the tutoring yet. I think it will come. So I'm just going off what they told me. If you run into any issues, please, by all means, shoot me an email, shoot me a text on Remind, all that great stuff, because I am here to help, and you can determine the direction of our class in the future. All right, guys, have a great day. Enjoy your weekend.